Hey everybody, in this video we are going to apply trigonometric identities to the example you see on your screen right now. We are given some details about alpha and beta. We'll be able to draw reference triangles, and then we will refer to those reference triangles to figure out the value of 15 times the sine of 2 alpha minus beta. We will use an angle difference identity, and then within that we will end up using double angle identities for both sine and cosine. So let's go. We're going to need both reference triangles for this problem. Tan of alpha is in quadrant 2. Opposite over adjacent is 4 over 3. The 3 is the negative. 5 is the hypotenuse. Beta is in quadrant 1. And cosine of beta adjacent over hypotenuse. 9, take away 4. So that makes this missing side root 5. It's not, excuse me, a Pythagorean triple. From here, 15 times sine of 2 alpha minus beta. 15 sine of 2 alpha minus beta equals 15. Okay, ready? Sine 2 alpha minus beta. I'm about to use the angle difference identity. Angle difference identity. That is sine of the first angle, cosine of the second. Sine keeps the same sign, minus cosine of the first angle, sine of the second. This and this require us to use the double angle identity. So I'm going to have to take this further. Equals 15 times, I'm going to fill in, what is the double angle identity? If it's alpha, it's alpha. If it's beta, it's beta. You stay consistent. That's 2 sine alpha cosine alpha. Drop down that cosine beta, it stays. Minus, in here, a little messier with cosine because there's subtraction. So you got to watch what you're multiplying. Cosine squared alpha minus sine squared alpha. Bring down the sine beta. Close the bracket. Sorry, I'm squishing. And I don't know how I'm writing. Sorry. All right. So that's where I am now. Equals 15 times. Do not write sine or cosine anymore. When you start putting in the answers like 4/5, -3/5, 2/3, 5, root 5 over 3, you're not writing the word sine and cosine anymore. You took it. Okay? So this required double angle. That's what we filled in the next step. So I have 2 times sine of alpha. What is sine of alpha? 4/5 times cosine of alpha. What is cosine of alpha? -3/5 times cosine of beta. What is cosine of beta? 2/3 minus cosine of alpha squared. Cosine of alpha was -3/5. It's going to be -3/5 in parentheses, then squared. It's going to be positive. You just understand. You are squaring the thing inside the parentheses. It's -3 times -3. It becomes +9. If the negative is not in the parentheses, or if there are no parentheses, you square the number and then multiply by the -1 after. Get it? Got it? Minus sine of alpha squared. Okay. Sine of beta. Beta, sine of beta. Now, are all of my parentheses like bookended, you know, like for instance, this is open and closed around that. That's important. Okay. And there's that. Now it's a little easier to see that everyone is accounted for. Okay. Negatives are where they're supposed to be. That 3 is negative. A lot of people will miss that. So here, less is more. 5 times 5 times 3 is the denominator. This is 2 over 1. If you multiply the top and bottom by 2, don't talk to me ever again. 2 times 4 times 3, pull the negative out front, times 2. Okay. Minus, that's 9 over 25, which is 5 times 5, minus 16 over 25, which is 5 times 5, which is going to give me negative 7 over 25, again, which is 5 times 5, times root 5 over 3, right? Okay. Here we are. 15 times 4 times 3 is 12, times 2, 24, times 2, 48, negative 48, minus, okay, I have negative 7 over 25, and I have root 5 over 3, but minus negative becomes plus 7 radical 5. This is 25 times 3, this is 25 times 3. I'm leaving it as 5 times 5 times 3. That's what they both are. Okay, I'm just showing you how to avoid making a mess. 15 can reduce with 15. Like if the numbers end up being bigger than this is manageable. You can avoid multiplying them all together by kind of doing work like that along your way. So that equals negative 48 plus 7 root 5 over 5. Or turn it around. 7 root 5 minus 48 over 5. If you try to tell me it's just the same as 48 minus 7 root 5, do you not know 2 minus 3 and 3 minus 2 are two different answers? Like, come on. I'm not finding cosine. What am I finding? Sine, sorry. So this was the answer to sine 2 alpha minus beta, minus, yes, with the 15 multiplied out front. So if you have one of these answers with 75 on bottom, you forgot to multiply it by 15, that is the final answer. Go through, watch it again, pay attention. It was like inception of trig identities. You had identities inside of identities, you know. Watch it, you put things in the right place. There's no point in making a bigger mess than necessary. They should have a common denominator when all is said and done, like if you're doing things correctly. If you have wildly different denominators, something's going wrong, like that's a red flag, okay? Check the playlist, comment, question, request in the comment section, and I hope you were able to follow. If so, let me know. If not, let me know, and check the playlist. Bye-bye.